Welcome back, Virtual Algebra 2. We're starting a very brief unit on trigonometry. We're really only going to study this one section where we talk about the basic right angle trigonometry stuff. Trigonometry means measurement of triangles. And it also has a lot to do with circles, but we're not really going to learn about that this year. If you do take pre-calculus next year, you're going to learn a lot of trigonometry, and hopefully what you learn now will help you. The right angle trigonometry in section 13.1 will let you solve problems like this example. If the sun is at an elevation angle of 35 degrees and it casts a shadow of a building 42 meters long, how tall is the building? Elevation angle means the angle above the horizon. So you can see that the sun in my diagram is 35 degrees above horizontal, 42 meter shadow, and h an unknown. So we'll learn how to do that in just a little bit. The main thing to remember for this section is the 6 trigonometric functions. You're very familiar with right triangles, I think. There's some familiar stuff here. The hypotenuse is always the longest side. We abbreviate that HYP. It's side AB in this triangle. And then, depending on which angle you're looking at or which angle you're focusing on, the other two sides, the other two legs of the triangle, will be called the opposite and adjacent sides. Now, opposite means across from in this situation. And if we're talking about angle A, then the side BC is the one that's across from or opposite angle A. Adjacent means next to, and really there are two sides that are next to angle A, but one of them is already called the hypotenuse, side AB. So the other side, side AC, gets called the adjacent side, abbreviated ADJ. So there are these 6 functions that are actually equivalent to ratios of sides in this right triangle, and they turn out to be really interesting and useful. The sine of an angle, the sine of angle A is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. I've written the first letters of those things in red because they form the easy-to-remember mnemonic SOHCAHTOA to help you remember how sine, cosine, and tangent are defined. There are 3 others called cosecant, secant, and cotangent, and they are defined to be hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. Cosecant is 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. We're really not going to do much with them this year, except just calculate them, but they do turn out to be interesting and useful, and you'll see a lot more of that next year. Alright, time to apply some of this stuff. Example 1 on page 829, we have this triangle here, and we're asked to find the 6 trig functions. Well, it's not too bad. We know all 3 sides, so we're looking at angle x, and that's pretty key. We're not looking for the angle, the trig functions of angle y. So which side is going to be the opposite side for angle x? It's not the side zx with length 5, it's the side yz with length 12. The adjacent side is going to be zx with length 5, and the hypotenuse is always the longest side, xy in this case. So we just use those definitions on the previous page to find sine of x, opposite over hypotenuse, or 12 over 13. Cosine of x, 5 over 13, etc., etc. Right? We're just using those formulas, those 6 formulas, those definitions we had on the previous page. Right? So that's what that should look like. So if you need to, pause it and look at these carefully to figure out how I got all those answers. The next example on page 830 is a little bit harder. We're looking for the 2 sides AB and BC. This is actually very much like the example I gave with the shadow in the beginning. We know the angle A is 41 degrees. Now, in this kind of situation, you have to select which trig function is best to use. And the one you want to pick is the one that connects things that you know with one thing that you don't know. If we were to use the sine of 41 degrees, we would find that the sine of 41 is the side BC over the side AB. But we don't know either of those sides, and so that's not the good one to use. It turns out that the best one to use is the cosine of 41 degrees, because that's the adjacent, or 7.4, divided by AB, the thing we're looking for. So that's perfect. Things we know, the cosine of 41 and 7.4, and then one thing we don't know, AB. So, using your calculator, make sure that if it has a mode button, that you check the mode. We want to be using degrees right now, not radians, so make sure it's in degree mode. Cosine of 41 is 7.4 over AB. Rearranging, we find that AB is 7.4 divided by the cosine of 41, which turns out to be 9.8. Try that now and see if you can use your calculator to get the right answer. Then to find BC, tangent is a good choice. The tangent of 41 degrees is BC over 7.4, opposite over adjacent. Rearranging, 7.4 times the tangent of 41 is BC. Okay, so try that and see if you can get that answer. There are always different ways to do problems, and in this case, once we have the side AB, we can use the Pythagorean theorem to find BC. And there are other ways to find BC as well. Okay, moving on to example 3 on page 831. Again, the name angle of elevation comes up. An angle of elevation is an angle measured above the horizon, and an angle of depression is measured below the horizon. Okay, so in this angle, it's the example from the beginning of the section about the puffins on the rocks. The photographer is 15 feet above the water, 40 feet away from the cliff, and the puffins are some unknown height above the water on their cliff, and we're looking for that. Well, we can draw a triangle like here, and realize that the length y plus 15 is the same as the length x. So if we can find y, which is the opposite of angle 28 degrees, then we can use the fact that just adding 15 to that gives us x. Tangent of 28 turns out to be the best one to use. It's y over 40, and we can find y and add 15 to get x. Okay, sometimes we have to use what's called the inverse trig functions. The inverse trig functions are defined like this. If the sine of angle x is equal to some number y, then the angle x is equal to the inverse sine of the number y. Okay, so that's the definition, and all other 6 trig functions have similar definitions. Here's an example. If we know that the sine of an angle x is 0.8, and we want to know what that angle is, it's just the inverse sine of the number 0.8. If you're in degree mode and you try that on your calculator, you should find 53.1 degrees. And you can check that by finding out, is it true that the sine of 53.1 degrees is 0.8? Yes, it is. Probably you have to press second sine to get that inverse trig function. Try to figure out how that works on your calculator and check it now. And there's another example with cosine just to show you how that works. So try those both now and see if you can duplicate my results. There's an important thing here that is sometimes a misconception. Inverse sine, although it looks like sine to the negative 1 power, which is usually you'd think of as 1 over sine, it's not 1 over sine. It's not the reciprocal of sine. The reciprocal of sine is something else. It's actually cosecant. So this is something special. This is something that you are going to need to use your calculator to do most of the time. Try to make sure you can find that sine to the negative 1, inverse sine button. Okay. All right, a vocabulary issue comes up. Your book asks you to solve a triangle. Solving a triangle just means finding all the sides and all the angles, and you have several tools at your disposal now to do that. You have, as always, Pythagoras. You know that the angles in a triangle sum to 180 degrees. You have your 6 trig functions, and now you have inverse trig functions. So let's try our hand at applying these tools to the solving of a triangle. Example 4. You've got this triangle here with 2 sides known and the angle, the right angle there, angle T. Well, if we use sine of r, we end up with 2 unknowns, the angle r and the side rs. Cosine of r has the same problem. So it's tangent of r that's going to help us quickest here. The tangent of r is 3.8 over 6.8, which is 0.559. That means that r is the inverse tangent of 0.559. So if you try that on your calculator, you come up with an angle r of 29.2 degrees. That's really the hard part, because once we get there, we have 2 of the angles, and finding the third, we just have to remember that the angles sum to 180. Subtracting, we get angle S to be 60.8. And then finally, using Pythagoras, we can figure out the final side, RS, to be 7.8. Here's your homework, guys. Good luck. This is the last new stuff of the year.